All right, welcome to another Live with Andrew math lesson. This is lesson 5 of our live math series that we have been doing over the past several weeks. We will be continuing this lesson series, and we'll be adding more, just kind of building to what we have here. But also on our YouTube page, be paying attention. We will be putting some more videos up for math skills as we go through. Uh, as always, want to make sure that you are safe and everything is going well during this time of crisis that we're in and the different things. You can see we have a little bit of a theme today that we'll be talking about in just a second. But again, we hope you're safe during this time and hope everything's going well for you. Please follow us on Facebook and subscribe on YouTube. We want to make sure that you're seeing this information and you're getting it out. So if you've somehow stumbled across this, please let us know if there's any way that we can help you, and go subscribe, like the pages, so we can make sure that you get the content when it comes out first thing. This lesson will be posted on YouTube afterwards, so if you are watching it now and you want to go back and see it again or see any of our other videos, go to YouTube and you'll be able to find it. As we always do and always talk about as we go through, everything that you had access to while you were in our program in person, we have the same stuff available. So if you have any questions about any of that, please contact your teachers. We'll be more than glad to help you get into there. And a lot of times people are embarrassed because, oh, I hadn't logged in before and I can't remember my login. Hey, that's fine. We'll be glad to help you. There's no time like now to start using it if you're not using it. So go ahead and keep going on that. And again, go to our Khan Academy webpage. You can go into there and do a lot of practice. A lot of the stuff we do today, we're going to do a few practice problems, but it'll be good to go on there and get more practice. Again, building that fluency up, you need to practice on these skills. So while there's not a lot to do, you're stuck at home, instead of watching the next series on Netflix or whatever, go on Khan Academy, work for a little bit. Not all day, every day, but just spend a little bit of time each day, and it'll help you build those skills that you have. We also have Smart Start classes available if you are looking to improve your work when you go back to work, or you're going to be looking for a different job. It's a great way and a great time to do that. In order to sign up, you'll just need to email me at adult.education@rcsd.ms, and we'll be more than glad to get you signed up. So today we are going to talk about algebra and expressions. Now, that's a lot of what we did last week when we were talking about algebra and expressions. We started it, and this week we are going into a little bit more on that. We're continuing kind of the progression of the math skills for the high school equivalency exams. If you're new to this and you go, ooh, I don't know anything about algebra, don't run, just stick around, because we're going to try to explain it in a way that it's not quite so scary, kind of like we did last week. We kind of introduced it and we talked about it to go a little bit deeper into what algebra is. And we started last week looking at the origins of algebra, which it came from the word algebrar, which was from Al-Khwarizmi, the father of algebra, and he was an Arabic man. He wrote a text, and this was in the 750s, around 800, so about 1200 years ago, so it's a pretty good while back. And he wrote a book called the Hizab al-Jabr wa al-Maqabala, which translates to the algebra, or algebra, that we get means restoration or completion, and in Arabic, Maqabala meant reduction or balance. So when we're doing algebra, that's what we're trying to do. We're trying to restore or complete. We're trying to reduce something and find a balance. And in looking at this, that idea is carried what we do in algebra. We talked about that last week, that restoring, completing, and reducing and balancing. And we want to just kind of keep that mindset of what we're trying to do there. We're trying to balance. Now, what this did, yesterday was Star Wars Day. It was May 4th. So may the 4th be with you. It's kind of a goofy pun, but we have nothing better to do. We're sitting at home, and it's one of those things that if you're a Star Wars geek like I am, you love these kind of things. But with yesterday's being Star Wars Day and looking at this talk of balance and restoration, and instead of saying, boom, there's our weekly theme on Star Wars, they shoot little guns, pew, 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 pew. So that was our theme. That's what kind of inspired me to look at all this together and say, okay, here's how we can kind of tie in what we're doing. Plus, I needed a good background, and the stars are a good background behind me. So our theme is balance and restoration, and it's similar in the movie Star Wars. There's good versus evil, rebels versus the empire, the light versus the dark side. So you see there's a balance there, and that versus is kind of like the equal. And if you've ever watched Star Wars, there's always a talk, and there's always a discussion and a fight about a balance in the force. If one person's really evil, then that means there's somebody on the opposite side that's really good. And there was always a kind of a fight in that balance. That's the same idea that we want to take forward as we're looking through the algebra stuff. So as we go into this and we're talking about bringing that balance to the force, that's what we're doing in algebra. We're trying to get a restoration and make things complete. In Star Wars, they also talk about your training is complete, or you must complete your training. We must restore balance to the force. We've got a few of those things and those ideas that we're trying to push forward. That's what we're looking at in trying to do this. We're trying to find a balance. We're trying to come up with a restoration there. Again, this is a review from last week's lesson, some basic terminology that we got to remember. In addition, we're talking about sum, plus, more than, increased by, added to, subtraction, subtract, take away, less than, difference, decrease, minus. Now, this week we're not going to be doing those algebraic expressions where it's like 4 plus a number equals this. But I want you to kind of remember these are basic operations. It was one of our first lessons we did when we talked about basic operations. Kind of think about, okay, when I'm adding something, what do I do when I add? When I subtract something, what am I doing when I subtract? Because we're going to be using those same skills as we go through the lessons today. So it's good to kind of keep refreshing your memory on this, not spending a lot of time looking at it and talking about it, but we want to kind of keep that in the forefront of our mind so we're better to answer what we're going to try to answer as we go through. In multiplication, you have a product, you have times, division, you have a quotient, you have divided by. So you can kind of see what's going on there. And again, I like this kind of going back to the Star Wars reference, the opposite of addition, subtraction, the opposite of multiplication's division. And you see how there's that kind of balance back and forth between them. So it's important for us to see that so we can carry that idea as we're going through. And as we talked about last week, expressions and algebra, they kind of go together there. And a lot of times on the GED test or the high set test, when you're taking those exams, and even the TABE test has some of this as well, expressions are the basis for a lot of math problems. Like they could throw a lot of different things at you using expressions. We see things about polynomials and people go, what's polynomial or binomial? I don't know what that is. It's just different types of expressions put together there with different terms. And it's important for us to have a pretty good understanding of how these kind of work, because we're going to use it in a lot of different ways over the next little bit that we're going to be doing this math. Now, with these expressions, you might have to factor or you might have to simplify expressions. Those are two of the things that they talk about, factoring and simplifying. Now, factoring can get not very difficult, but it has a lot of different kind of parts to it. We're going to look at kind of a simpler part of factoring, and then we are going to also look at simplifying expressions to see how we could better simplify. And I took this from some of the packets that I've put together. If you've ever done one of the packets that I've given, I call it my Pass the Math Test packet. These are the first several pages of that packet that we're going to be kind of talking about today. And it's a good skill to have. You'll use it in a lot of different applications going through in your preparation for taking the HSE. So let's look at a few of these that we have to factor. So this first expression that we have to factor there, it's 16a plus 4b. Now, this is just an expression. It's not an equation, because an equation has to have an equal sign. So when I was talking about a balance to the force, and I was talking about a balance in algebra and that connection, if it has the equal sign, whatever you do to one side, you have to do to the other. On this, we're just simplifying what's there by factoring out. We're trying to find what's a common thing that these two terms have that we can take out. Now, even though there's not an equal sign, we still, if I take something out of the 16, I have to be able to take the same thing out of the 4. I can't take 10 out of 16 and not do anything to the 4. I have to do the same thing there. So that's where there's still that balance that you have to do. You have to make sure that you're doing the same thing to each part. So when we look at this, we have to find out what each term has in common. So as I'm looking at this and I'm trying to see what's there, I can see that there's a 16a and a 4b. Now, A and B, those are different. But if I look at 16 and then I look at 4, with both of those, I know that those numbers have a connection. Again, this goes back to our first lesson that we did when we were talking about the parts of the lesson that had, I had somebody say you can't see the problem. All right, let's see if that can fix that. There you go. Hopefully you can see it now that's there. But as we look at it and we see 16a plus 4b, we know A and B don't have anything in common. Those are kind of different. But 16 and 4, like I mentioned a second ago, it goes back to the first lesson that we had. And we were talking about multiplication. You've got to know the, let's see, make sure that we can see everything. If you can see me, send a message in the chat, because one person said they can't see the problem, but I'm watching it on a separate screen and I can see it. So if you are, you may need to swipe left or right and you might could see the PowerPoint. You may just want to check that. And all right. So Ms. Gayla, if you're having a problem, you might have to change something. You might have to come out and come back in or something, because I think it's still working on the other side. So as we're going and we're looking at this and we're thinking back to those multiplication tables, this is where it's so important to know your multiplication tables. If you see 16 and 4, yeah, you could get out a calculator and you could start punching in, okay, what goes into 16, what goes into 4, and you could do all these things. But if you just know in your head, well, 4, 8, 12, 16, 20, 24. I know the multiples of 4. I can tell you right now what the multiples of 4 are, and I know that 4 goes into 16. Now, this one's pretty simple. You can just look at it and go, oh, yeah, that's 4 goes into 16. So when I see that common that they have, I see that common answer there, I can take out what they have in common. And in this particular one, I can divide both sides by 4. If I divide both sides by 4, because I know 16 and 4 are both divisible by 4, that leaves me with 4a plus b. And if you notice there, I put a parentheses because all I did was took that 4 out of the problem and I put it on the outside and I simplified, and because I factored out the 4a plus b. And the way you can check this, you just multiply it back in. And I'm not doing a lot of that today, although it would have been a good place we could have done this. Multiplying 4 times 4a gives you 16a, and multiplying 4 times b gives you 4b. So when you put it back and looking at it, it helps you to see what the answer is there. But all we're doing is taking out what they have in common. So 16A plus 4B, 4 was the only common thing that they both had. That's one of the things you have to do when you're first learning to factor out expressions. You're trying to see what do they have in common and what can I take out. So let's look at another one and see if we can do it. All right, if you're watching this on YouTube, hit pause. You can take some time to work it and then press start or play when you're ready to go to the next one to see the answer. If you're here live with us now, take a couple seconds and see if you can find what these problems have in common, or these two terms have in common. If you're looking at it, we see it's 10x plus 2xy. I notice, and just in looking at it, if you're unsure, look at it and see, okay, well, I see there's an x in both of them. So they have an x in common. We can take out an x automatically. I know I can take an x out. But then what about the numbers? Did they have some sort of common? Okay, well, 2 goes into 10. I know that. How many times? 2 goes into 10? 5 times. But what I can do is divide both sides by that 2x. That's going to cancel out, like we talked about last week. We did this a little bit. We canceled out the 2 and the x. They cancel each other out. The x cancels out, and then 2 goes into 10 5 times. So that leaves us with 5 plus y, because we took out the 2x. We found what they had in common and we put it there. And this is just doing this step by step as we go through. And if you notice there, I'm just talking through on the side of the page there what we're doing. We look at it and we go, okay, this one, okay, I know 10 and 2 are both divisible by 2. I know I can do that. And if you notice here, I mean, you can look at 2, not a lot goes into 2. And if it goes into 2, then I know it'll go into 10. So I can look at the smaller number and see what I need to do with that. And then when I get to the end, if I wanted to check it, I could multiply the 2x times 5, which would give me the 10x, and I can multiply 2x times y, which would give me the 2xy. So you can see how this is set up, and you see how this one goes. Now, this is for factoring. Let's look at one that's a little more complex. Now I have 3 terms here. All right, I have 3 different terms in this expression. Now, when I'm looking at it, I need to determine what I could take out of each one of them. So take a couple seconds. If you're on YouTube, hit pause. See if you can work this one out. If you're here with us, take a couple seconds to see what they have in common. Sometimes I look at the letters first because that's just easier to me. It's easy to see which letters are different, and then I can think about the numbers. So looking at the letters, there's just 2 letters. There's 3 terms. So I know I can't take a letter out because the last term doesn't have a letter. So I know that's not going to be that. And remember, it has to be equal into all of them. It can't just be into a couple of them. I look at the next one. What can I take out? Well, 10, 5, and 15 all are multiples of 5. So I know on this one, I can divide them both by 5. And I realized there, I wrote the wrong thing. Hold on one second there. That shouldn't be a 2. And that shouldn't be a 2. When I do these, I copy and paste, and apparently I copied and pasted too quickly. So I know that 10, 5, and 15 are all divisible by 5. They're all divisible by 5. And there's an x in both terms. No, it's not the x, so I don't need to worry about that part. On that one, it needs to be the full thing, which is, let me get it. it's only going to be the 5. That's the only thing. So we don't need to worry about the x there. We are just looking at the other part. All right, so that's what we want to look at there. All right, don't want to look at that, only want to look at the other part. Okay, so we see that you could take a 5 out of all of them. So in your final answer, we took a 5 out. 5 goes into 10A 2 times, 5 goes into 5 1 time. And if you notice there, I just left the B because I don't need to put a 1 there. I could put a 1 there, but it doesn't have to be there. It's just there for a place saver, but it's easy there just to leave the B. That's usually what you see. And then the last one, 5 goes into 15 3 times, and that would be our final answer on that one. That leaves 2A minus B plus 3. All right, so that's how we just take out. We just saw what they had in common, and we went from there. All right, so here's a little bit of time. See if you can do these next two. If you are working here live, I'll give you a few seconds to work it. If you are working on YouTube, just hit pause and we will start back in just a second. All right, so let's look at these now. On the first one that we have there, 6x plus 12y. Again, I like to look at the letters first. On the letters, there's nothing in common with the letters. So I know that 6 and 12, 6 is a multiple of 12. 6 goes into 6 once, 6 goes into 12 twice. So I know that's what I'm going to have to do. So the first thing I do is divide both sides by 6. When I divide both sides by 6, that's going to leave me with x plus 2y, and the 6 goes on the outside of the parenthesis there. So I see I took out the 6, and that goes on the outside there, and it left me with x and 2y. And that would be the answer to that one. For the next one that we have over there on the right side, we see 27x plus 3xy. And looking at it, I can see, okay, there's an x in both of them. So I know I can take an x out. Well, can I take something else out? I look at my multiples. I know my multiples of 3. 27 times is 3 times 9, so I know that's going to be it. So then I divide both of them by the 3x, and that helps me to reduce it down to 3x parenthesis 9, because 3x goes into 27x 9 times, and then 3x goes into 3xy. You cancel those out, and you're left with just the y. So 3x times 9 plus y. That would be your answer for that one. Hopefully you got it. If you did, good job. If you didn't, let's keep working on it. Let's keep seeing what we can do to improve those. Again, Khan Academy is a great place to work on expressions and factoring expressions. If you need help getting some of those, I'll be more than glad to send you some links to some of those lessons, or you can just go in there and search for it, and it would be able to kind of get you guided into that spot. There's also videos that are probably a little more thorough than what I'm doing, and they give a little more work out the problems a little bit differently and things for each one. So I highly encourage you to go to there. Now, like I said a second ago, expressions can be the basis for many math problems, and you might have to factor or simplify an expression. Same slide we saw just a second ago. What we've been doing is factoring, but when you factor, you kind of are doing some of the steps of simplifying. So that's one of the good things about this is it goes hand in hand, and it helps you to learn how to do this a little bit better. So as we look in this one, let's look and see how we are simplifying and factoring the expression. Here we have more exponents. All right, so we see the exponents now aren't just a single number, it's an actual to an exponent. It's not just a variable, it's a variable with an exponent. It's raised to an exponent. And on these terms, we have to look at it and see, well, what do they have in common? We're still looking at the same thing that they have in common. Now, a lot of times people say, well, they have an x, but not just an x. How many x's are there? In the first term you see there, 24x to the fourth power plus 4x to the third power. So the first one has 4 x's and the second one has 3 x's. So as we look at that, we know, and we'll talk about this and break it down a little bit in just a second, we know that an exponent means that's how many times you multiply it. So really there's 4 x's. We're multiplying it 4 times, and then on the other part, we're multiplying it 3 times. So if we wrote it all out and put all those x's there, we would have 4 x's on the first one and 3 x's on the second one. So when we're looking at this and trying to see what we can cancel out, what could we take out? What do they have in common there? Well, when we see it and divide, we know it's going to be something with the x. Well, how many x's can we take out? And then with the numbers, 24 and 4, do they have a common? Well, yeah, 4 goes into 24. I know it's a multiple of that, so I could divide both of them by 4. So I'm going to divide them both by 4x to the third power. And when I do that, it's going to cancel out, and this is where we've looked at this before, and when we saw these at the very beginning, the x3, whoops, I have the wrong color. Hold on one second. When I look at it and see, okay, this is x3, these two cancel out on that side, and the 4 cancels out. And on the left side, I have 3 x's that are going to cancel out, and it's going to leave just 1 x. So they cancel out, leaving just 1. And then 4 goes into 24 6 times. So my answer there is going to be 6x plus 1. Now, when you see this, you may go, well, okay, earlier you didn't put a 1. You just left the b, but here you put a 1. Why did you put a 1 now, but you didn't put a 1 before? Well, on the one before, there was a b that was holding that place. If we would have taken away the 1 and not put it there, it would have taken away the place of that 1, and that spot would have been lost. So you've got to make sure that the 1's there to hold the position if there's no other variable. If it's a 1 in front of the b, then it doesn't have to be there because it's understood there's a 1 and the b's holding its place. But if the b's not there, the 1's going to have to hold its place. So as we see this, we took out 4x3, and that left us with 6x plus 1. All right, so you can see how that works out and how we are kind of simplifying with those numbers there. And we're going to talk about this a little bit more and see it as we go over the next few slides. Whenever we are simplifying that problem that we just had, we had to divide the exponents, which is called canceling. And you saw me, I marked them out saying we canceled. But what we were doing there is actually dividing out those. Because if you look at that, it's a division problem. It's a fraction, which is just division. 24x to the fourth power over 4x to the third power. When we see it that way, it's just dividing. We're dividing 4x to the third power into 24x to the fourth power. And what we do, we call that canceling. And this is something that you'll have to do on some of these problems. You'll have to simplify expressions, and this is the method that you're going to be using to do that. So let's look at a few of these. All right, so if we have 9xy over 3x. Now, this is what we were just kind of doing when we were factoring out. We had to divide to see which one went into each one of them to see what was left. So now we're just doing one little part. We're actually doing one simple part of the problems we were just doing. So you should be able to see what this is. So we look and see, okay, what does each one have in common? What can we do there? Just like we've done. And I know that the 3 goes into xy, and 3 times the x cancels out. So I know that those can go into each other. The 3 goes into 9, the x goes into x. So that x is canceled. 3 goes in there 3 times, so that leaves me with 3. And then I just bring the y answer down. All right, so on that one, I just divided it out, and that's what I'm left with. All right, so let's look at the next one. 42 xyz over 6xy. So the first thing I'm going to do is find out what each one has in common. And I have a little note there in parentheses, just like reducing fractions. If we were reducing fractions, we would say, okay, what do they have in common? Again, this goes back to the very first lesson we did. And we talked about basic operations. Yes, this is a division problem, but division is just multiplication. It's just the opposite side of it. So if you know your multiplication, you should know your division. You'll be able to kind of work those side to side. So we see this, we find out what they have in common. Take a couple of seconds to look and see what we have in common there. All right. Now, as you've seen it, we know that 6xy goes into 42xyz 7 times. When we cancel it out, we know that the xy cancels with the xy, and we know that 6 goes into 42 7 times, and that leaves us with just the z being brought down because the other 2 variables canceled out. I like these because they're pretty simple. It's just a matter of, oh, there's an x here, mark it out. There's an x up here, mark it out. Bring the z down to the bottom. Divide the numbers, and I'm done. It's not too much there. Now, you may go, oh yeah, that is pretty easy. That's the steps of algebra. That's what we're doing here. These are the things when people always say, oh, don't give me numbers and letters. It's actually not that hard when you see that it's just little steps that you're going to take each time. All right, now let's get it a little more challenging here. We see 4x over 5 times 9x over 3 times 15y over 2xy. And again, we're going to do this and simplify and figure out what we can do there, what can match up. Now, a key thing to notice here, it is not adding and subtracting. I am multiplying straight across. You have to understand this is in multiplication. You can do what we're about to do. If it was an addition or a subtraction sign in between, there's different rules on that, and that's not what we're doing. We're doing just this with the multiplication. I can look and see what I can reduce things by. Like we did on the last one, we saw that 6 went into 42. Well, on this one, we're trying to see what we can find that goes into what. So in just looking at it, I see that there's a 4 here. Okay, on the bottom, I see there's a 2 here. I know 2 and 4 match up. I see there's a 5. And I see there's a 15. I know those match up. Now, there's also a 3 right there. And 3 could have gone into 15, but also 3, I know that 3 goes into 9. And 5 wouldn't have gone into 9. So I can look at them and kind of see, okay, where's some commonalities that they have? Where's some same things that I could see that they match up with? Sometimes they match up like this evenly. Other times they don't match up so well, and you have to kind of to look around and see. I can also look at my variables. I see that there's an x right there, and I see there's an x up here. I see there's a y over here, and I see there's a y over here. So I can see those different parts that they have in common. So what I'm going to do to make that a little easier, I rewrite it on the next line, just moving things to where they fit. I'm putting them under the one that they kind of match up with. Now, I didn't move the letters. I left the letters with the term they were attached to, which you can do that just fine. And you don't have to move them. The reason I do this is just so it'll be a little bit easier to see what's dividing into what. All right, once I do this, I can see where they match up. Again, I have the 4 and the 2, the 9 and the 3, the 15 and 15, the X and the X, the Y and the Y. I'm looking to see what matches up with each other. I know with 4 and 2, that's going to leave me with 2. I know 9 and 3 is going to leave me with 3. I know 15 and 5 is going to leave me with 5. So across the top, I'm going to have 2 times 3 times 3. And I cancel out an X, a Y, and a Y. So that's going to leave me, I'm left with one X that doesn't get canceled out. So if I say 2 times 3 times 3, that's going to give me 18, and then there's an X. So that's all that's left when I reduce it. Now, all I have to do is just multiply those numbers, and it leaves me with 18X. Now, this seems like, oh my goodness, what all did you just do? Again, look at it in just a small part at a time. If we look at just the first little part here, that's just like we did on the last page. We're seeing how could that reduce down. If we look at the next one, just one little term at a time, how would that reduce down? And then the last one, how does that reduce down? Now you could multiply it all the way across on both of them and then divide it out at the end. It just makes bigger numbers. This is a way to kind of simplify it as you go, just to keep it a little bit easier as you're trying to work this out. All right, let's do one more here, and then I'll give you a chance to, or actually do a couple more to practice a little bit. All right, so we have 10x over 3y times 9y over 5. So again, we're looking to see, okay, what do they have in common? What can we kind of match up? Hopefully, if you're on YouTube, you can hit pause, take your time to look at it. If you're here with us live, take a couple seconds to look and see what they have in common. And just like I did last time, the first thing I'm doing, I just swap them around, match them up, because it's multiplication, because there's that times symbol in the middle. I can move those around. It doesn't matter, because 2 times 3 is the same as 3 times 2. It doesn't matter the order they're in. It's still multiplication. That's part of the associative property that we've covered on a little bit in the past. So now I can see 5 goes into 10 2 times, and that's going to be 2x. I know 3y goes into 9y 3 times. So 2x times 3, I should have 6x. Again, 10 and 5 match up, 9 and 3 match up, the y's match up and cancel out. So I'm left with 2x times 3, which gives me the answer of 6x. I just do one part, and that gave me the 2x. I do the second part, 9y divided by 3y, which leaves me with 3. And when I multiply those together, that's what gives me 6x. All right, so now I'm gonna let you have some time here. If you're on YouTube, hit pause, work out these 2 problems. And when you get done, you can hit play and see if you had them right as we go over them together. If you're here with us live, take a couple seconds to work these out, and we will start back in just a second. All right, we will go ahead and start working over it now. I've gotten a few answers coming in on the chat box. I appreciate that. So now, as we are looking at this, we are going to start with the one on the left, 18ab divided by 6ab. So just in first looking at it, I see, hey, there's an AB on the bottom, there's an AB on the top. That means that's going to cancel each other out. So I'm not going to have any variables left in my answer. And then I know 6 goes into 18 3 times. So that's pretty simple to just 18 divided by 6, which gives me the answer of 3. So again, you see here, I match up the 18 divided by 6. I know AB and AB cancel each other out. So that's going to give me 3 is all that I have. So just like I said, that's what the answer is to the first one, is 3. Now for the second one, it's a little trickier. We kind of look and see, well, what matches up? I know 9 can match up with 18. I know 7 can match up with 21. I see there's a C, an A, B, and an A on top. So 2 A's and a B and a C. And then on the bottom, there's an A, B, and C. So I kind of see what matches up there. And you can see here, when I do this, I see that there's 9 divided by 18, which is going to leave me with a 2. When I have that 2, the reason I have an arrow there, now there's a 2 on the top up there and a 2 on the bottom now that can cancel each other out. So that 2 and 2 can cancel out. And then I have the 27 and the 21 and the 7. So that's going to leave me with a 3. This one's going to leave me with a 2 on the bottom, which ends up canceling out. So it's just 3 is the only number that I'm going to have left. But now I have to look and see, well, what variables will it be? Well, the variables that cancel out, A cancels with A, B cancels with B, C cancels with C. So that's going to leave us that 1A. So we had a 3 and we had A. So we put those together, and that's our answer to this one. 3A is the answer to that one. And as you saw there, I made it a little tricky because you had 2 steps there. You could have simplified. Now, if you didn't simplify when you got to the end, you would have had a 2 on the top and a 2 on the bottom, and you would have had the 3. So you would have said, well, it's going to be 6A over 2. Well, 6A over 2, you could have simplified that a little bit more. You could have divided both of them by 2, the top and the bottom, and that would have canceled out. So that would have left you with just 3A if you would have done it that way. All right. If you have any questions, you can send it in the chat box, or you can send a comment or an email to me through the YouTube channel, and I'll be more than glad to explain this and give you some more information there. So let's think about what we learned today and think back to the lessons that we've had. We've had these variables a minute ago that we talked about, and we had the exponents with different numbers. So you see this, and I'm asking here, what's the answer to this? If I was just going to multiply A to the 4th power times A to the 3rd power, what would that be? Because we're looking at this just now. We were looking and simplifying some of these, but what am I going to do on this problem? If you want to pause it on YouTube and try to think about what this answer would be, if you think you know it, you can put it in the chat box. But just kind of think for a second, what am I going to do here? I like these problems because this is kind of what we've been doing, and it kind of takes it just a little bit further, and it looks hard, but we're going to look and see how it's actually pretty easy when we know the rule to it. Let's look at what the exponents mean. So in that one we just had, when we say A to the 4th power times A to the 3rd power, all right, now think about if we put numbers in instead of variables. And I do this sometimes. Like if I'm trying to figure this out myself, I would work these out to see, okay, what does this mean? Because when I see the letters, that messes me up sometimes. So let me just put a number in there. If it was 2 to the 4th power, what would that mean? Oh, well, I'm going to write 2 4 times. Okay, so all I do here is I'm saying A 4 times, so I wrote it out 4 times, and then it said A to the 3rd power 3 times, and I'm multiplying. So I just bring the multiplication sign down with it. So what this says is we're actually multiplying A how many times? 7 times. So if you notice here, we said A to the 4th power times A to the 3rd power. All we did was just added what the exponents were. Here's 4, here's 3. What's 4 plus 3? That gives us 7. So we see, okay, if you multiply exponents, and it's just variables, the same variable with the exponents, you add them. Okay, so when exponents are multiplied, you add them. So when exponents are divided, what do you think we're going to do? If when you multiplying, you add them, when exponents are divided, you are going to subtract. Now, again, remember at the very start of this lesson, we talked about the opposites. Opposite of addition, subtraction. Opposite of subtraction is addition. Opposite of multiplication is division. Opposite of division is multiplication. So you can see the connections that these have. And with exponents, it's the same way. So if you see this one here, x to the 7th power, over, and x to the 7th power, 7 to the 5th power, over x to the 3rd power, y to the 2nd power, what are we going to do here? On the last one, when we were multiplying them, we just added them up. So here, like it says, we're going to subtract them. We look and see how many x's do we have? There's 7 x's. There's 5 y's. We have 3 x's and 2 y on the bottom. So I'm going to take these 3 and mark them out. And I'm going to take these 3 and mark them out. And that's going to leave me with 4 x's. Over here, I'm going to mark out 2 y's. Over here, I'm going to mark out 2 y's. That leaves me with 3 y's. So my answer is going to be x to the 4th power, 3 y to the 3rd power. So all I do, and if you want to draw them out like this, you can. Sometimes if you get into big exponents, you're going to be drawing a lot of x's across your screen. But this is a way to see what you need to do and how they cancel each other out. All we did, though, if you look here, what's the difference between 7 and 3? Well, that was 4. So x, 4. What's the difference between 5 and 2? That's 3. So y is 3. Pretty simple just to look at that and to figure out how to reduce it. So let's simplify these real quick. If you're on YouTube and you want to pause it for a second, press the pause button. If you're here with us, take a couple seconds to work that one out. We see the first one, a to the 5th, b to the 9th over a to the 5th, b to the 2nd power, or b2. So I just subtract. What is 5 minus 5? 0. What is 9 minus 7? 7. So on that one, it would just leave us with, there's 5, there's 9. We could cancel if we want to. I'm canceling out 5, I'm canceling out 5, canceling out 2, canceling out 2. That leaves me with these, which how many is that? That would be 7. So my answer to that one is B7. All right, the next one. M4, N5 over M5, N7. What am I going to do here? All right, I look at it. If you're on YouTube, hit pause, take a couple seconds to think it out. All right, as you're doing this, if you wanted to just write it out like I did here on the screen, got 4 M's at the top, 5 N's at the bottom. So I'm going to cancel out 4, cancel out 4. That leaves me with just 1 M, and it's on the bottom, not the top. That's a key thing to remember. Same thing on this one. There's 7 N's. I mark out 5 N's on both of them. That leaves me with N to the 2nd power. So when I get my final answer, I put a 1 to hold the spot over M N squared. Again, that's something, if y'all have watched my lessons, you know, I challenge you. We didn't go over that. We didn't go over the bottom being bigger than the top. But what have we talked about before? If you run out of the variable, you put a 1 to hold the place value. So that's all we had to do there, is put that 1 to hold the place value, and then we put the numbers there to be, or the variables on the bottom, because that's where there was more. All right. This is where we're going to stop today. Again, if you want more practice on this, on algebraic expressions, let me know. You can email me. I will gladly send you some work you can do. I can send you to different Khan Academy pages that'll let you work those out. Also, you can just go to Khan Academy yourself, use the class code, go in there, and you can just search for algebraic expressions. The reason I say to sign up and go into our class versus just going there on your own and just doing lessons, if you create a profile and you work, it will remember what you're working on and help you learn new skills. It'll also say, hey, you're having trouble with this skill. Let's go back and work on this. Because as you can see from here, we've talked about multiplication a lot today. If it notices you're bad in multiplication and you need to work on that, it's going to help you work on those skills that can help you do the later skills. And that's what a lot of people don't like to do. They don't want to do the steps to get to where they need to be. They just want to be there. It's the same way we want to lose weight and be healthy, but we don't want to exercise and eat right to get there. We want to have a lot of money, but we don't want to work and not spend money. We want to spend it. We don't want to save it. So the same thing happens in math. People don't want to put forth the effort in to get the end result. And you've got to do a little bit of that, as we've talked about. All right. So next week, we'll be back live with Andrew. Look for this lesson later today on YouTube. We'll be more than glad to help you out any way that we can. If you have any questions or you have any other lessons that you want to see, chat me up in the chat box, send me comments on the YouTube channel, or send an email to adult.education@rcsd.ms. We'll be more than glad to work that out. Make sure you tune into YouTube and check for new content. We're having a couple new lessons that will be uploaded in the next week or so as well on other math skills and other subject areas. I have a science video that I've recorded a few sections for, and I'm trying to edit it and do. It's not live, so it's a new world, but we're going to do some science stuff and just put a couple of new things of content up for you. So if you have any questions, please put it on there. We'd love to see you back. Have a great weekend, and we'll see you next time.